Hello, good day. Today I'm going to give an example on how to find the root of a logarithmic equation using secant method. So here's my example. Find the root of the logarithmic equation x log 10 4x plus 6 is equals to 10 by using secant method. Calculate its absolute relative error. So here we can see the formula of the secant method. So we have x sub n is equals to x sub a minus f of x sub a times x sub a minus x sub b over f of x sub a minus f of x sub b. So first we're going to rewrite our example into general form. So we have f of x is equals to x log 10 4x plus 6 minus 10. Now, in secant method, we're going to have two initial guesses. So, we have x sub a and x sub b. Now, suppose we have x sub a as 21 and x sub b as 20. Now, we're going to substitute the x sub a to this example. So, we have x sub a is equals to f of x sub a. We have 21 log 10 for 21 plus 6 minus 10. So we have x log 10 for f of x plus 6 minus 10. So we have 21. So we have 31.0039. Now for the f of x sub b, we have 20 log 10 4 times 20 plus 6 minus 10. So we have x for alpha x of 20, we have 28.689. 28.689. Now on our table, so this is the first iteration. So in the first iteration, you have x sub a is equals to 21, x sub b is equals to 20, and our f of x sub a is 31.039, and our f of x sub b is 28.689. Now for the second iteration here, the x of a of the second iteration will be the x sub b of the first iteration. So we put 20 here, and the f of x sub a of 20, so we have 28.689. And then for the second approximation, we're now going to use the formula of the secant method. So we have x sub n is equals to x sub a, which is 21, minus f of x sub a, which is 31.039, multiplied by 21 minus 20, over f of x sub a is 31.039 minus 28.689. So we have the answer. We have 21 minus 31.039, 21 minus 20, so 31.039 minus 28.689. So we have 7.792. So here in the second iteration, the 7.792 will be our new value of x. So we have 7.792. Now this value will be substituted to the example. So we have f of x sub n is equals to 7.792 log 10. 4 times 7.792 plus 6 minus 10. So we have alpha x log 10 minus 4 alpha x plus 6 minus 10 called 7.792 2.234. So we have 2.234. Now we're going to put 2.234. Now to calculate the relative error for the second iteration, so we have is equals to absolute value of the x sub minus 2.234 over the new value, which is 7.792 times 100%. So we have 7.792 minus 2.234 7.792 times 100. We have 71.33%. So in the second iteration, we have 71.33%. Now for the third iteration, our x of a will again be the x of b of the second iteration. So we have 7.792, and our f of x sub a is 2.234. Now again, on the third approximation, to find the new value or the x sub b, we're going to use the formula of the second method. So we have x sub n is equals to 20 minus f of x sub a, which is 28.689 times 20 minus 7.792 over f of x sub a, which is 28.689 minus 2.234. So we have 20 minus 28.689 times 20 minus 7.792 over 28.689 minus 2.234. So we have 6.761. 6.761. Now, the third approximation or in the third iteration, the new value is 6.761. Now, we're going to substitute this to the example. So we have f of x sub n is equals to 6.761 log 10 times 4 times 6.761 plus 6 minus 10. We have alpha x log 10 for alpha x plus 6 minus 10 of 6.761. So we have 0.271. So the f of x sub b for the third iteration, we have 0.271. Now, to calculate the relative error for the third iteration, so the new value 6.761 minus the previous, which is 7.792, over the new value of x, which is 6.761, rather, multiplied by 100%. So we have 6.761 minus 7.792 over 6.761 multiplied by 100. So we have 15%. So we have 15.25%. Now for the fourth iteration, in the fourth iteration, the x sub a will be the x sub b of the third iteration. So we have 6.761, and then the f of x sub a is 0.271. Now, to find the value of this x sub b for the fourth iteration, we're going to use the formula of the second method, which we're going to substitute everything. So we have x sub n is equals to 7.792 minus f of x sub a of the third iteration. So we have 2.234 multiplied by 7.792 minus 6.761 over half of x sub a, which is 2.234 minus 0.271. So we have 7.792 minus 2.234 multiplied by 7.792 minus 6.761. 2.234 minus 0.271. So we have 6.619. So we have 6.619. So 6.619. Now, we're going to substitute the new value to the given example. So we have f of x sub n is equals to 6.619 log 10 times 4 times 6.619 plus 6 minus 10. So we have alpha x log 10 4 x plus 6 minus 10 6.619. So we have 0. 0.005 so 0.005. Now to calculate the relative error of the fourth iteration, so we have the new value 6.619 minus 6.761 over 6.619 multiplied by 100%. So we have 6.619 minus 6.761 over 6.619 times 100. So we have again 6.619 minus 6.761 over 6.619 times 100. So we have 2.15%. So we have 2.15%. Now, in my case, the x log 10 for x plus 6 minus 10, the root can be found at the 6th iteration. So, that's how you find the root of a logarithmic equation by using secant method. So, that's all, and thank you for watching.